Hi Year 12, I'm going to explain these three examples to you. First of all, if we're going to differentiate this function, then we'll use the notation d by dx of x squared plus 3 to the power of 4 is equal to, remember we bring the indice down to the front and this becomes 4 times x squared plus 3. Take 1 off the indice, which is 3, and then we need to multiply it by the derivative of what's inside the brackets, and the derivative of that function is 2x. So then we end up with, let's bring these to the front together. 4 times 2x would be 8x outside of x squared plus 3 all to the power of 3. So if we differentiate this and get a result of this, that process is differentiation. The reverse process, if we wanted to take this and find what our original function is, then that's the process of integration. And that's exactly what this next part of the question's asking. Notice the integral that they're asking us to find is the same as the result that we got here. So if I'm going to go back and integrate 8x outside of x squared plus 3 to the power of 3, then my result must be my original function, which is this one here. So I end up with then my original function, which is x squared plus 3 all to the power of 4. Don't forget, because this is an indefinite integral, I also need to include my plus c. Now, notice the next question is a little bit different. We don't know what the integral of 40x times all of this is, but we do know that the integral of this result here is equal to this. So how about let's start with what we know, and let's put, after the integral sign, let's put 8x times x squared plus 3 all cubed dx. Because I know that result, the integral of this, is my original function, which is what we found in the previous example. But in doing that, I've actually changed the question. I can't change the question. I still need to be finding 40x times all of this. So I want you to think about what you could take out the front of the integral sign so that you weren't actually changing the question. You were still finding the integral that was required. But we're using the result from the previous part to actually help us get there. So obviously 8x times 5 will give us 40x. So now you can see that this is in fact the same question that's being asked, but the reason I included this here, because I know the result for that is going to be this here. So now let's leave the 5 out the front, and we know that the result from the integral of all of this is going to be x squared plus 3 to the power of 4 plus my constant c. So now we'd say that this is 5 times x squared plus 3 to the power of 4. And I know you're probably tempted to go, well, I've got 5 times c, which is 5 times my constant. But 5c, well, the constant, we don't know what it is. 5 times some constant is still going to give us a constant. So all I need to leave this as is 5x squared plus 3 to the power of 4 plus a constant c. We don't need to write 5c. So now I want you to sit and look at that very carefully. Look at part A, part B, and part B, part 1 and 2, and see how we use the results from part A to answer this. We use the results from this to answer this. This is another way of integrating. I like to call it, the textbook calls it the reverse chain rule, but I like to call it differentiate, hence integrate, because that's essentially the process that we've done here. Differentiate this, hence integrate using your result. So take a moment to look at that carefully, and then I'll go through the next example.